Hi everyone! In this video series I'm showing you the foundations of planet editing and how to use the SimpleRockets2 Planet Studio, a tool for the design of custom celestial bodies and stellar systems. In episode 3 we looked at parametrical editing in Planet Studio, covering website uploads, metadata, general properties, quality modes, atmosphere visuals and physics, water and rings. As the last few episodes have been quite intense, I want to make this video a little more relaxed and take a deep dive into the possibilities unlocked by the recent addition of structures, or planet objects. First, we'll start by discussing how structures and launch locations are managed in the game. Then we'll look a bit closer at the available structures. Finally, we'll examine some good procedures for maximizing detail and performance, and for creating unique constructions. Planet objects are divided into three main categories: launch locations, structures, and substructures, which for clarity I will be calling components for most of this video. All players will be familiar with launch locations, but structures are new, so it's worth going into a bit of detail about how they work. Different to all other parts of the planet, structures are made independently of the quad sphere. In other words, they're 3D models in their own right. This means that they can be placed at any coordinate within a planet's sphere of influence. They can be stacked together, intersected, scaled, rotated in any direction. In addition, there are two light source components which will automatically turn on at night to provide illumination. Now, while they behave entirely differently to the planet's terrain quad sphere, structures do still share one key characteristic with the terrain: levels of detail. These enable the models to be loaded in incremental detail based off the distance between the structure and the player's craft. And as we'll see in a bit, this can be used to improve performance and smoothness in completed structures. Similar to the organisation of containers and modifiers in the Terrain Generation tab, there is a clear hierarchy to planet structures. At the top of the Planet Objects tab are these three main buttons. The first adds a new launch location, the second adds a new structure, and the third adds a new substructure or component. Let's go ahead and add a new structure. Clicking on this has now shown up this set of gizmos on the planet's surface. You can see it's also opened up this structures box with the name and several other parameters which we'll be investigating. In addition, the delete button and this move view to target button. Selecting this puts the camera into an orbit view. That is, we're controlling the view using the mouse scroll wheel and the left mouse button to orbit around these central coordinates. The name can be changed here. The latitude and longitude can be either manually inputted or dragged using the gizmos. The elevation, which is above ground level and by default you can see is updating as we move the structure, and the heading or rotation of the main structure. The next option is this switch visible in map view. This is a really useful feature, so let's go ahead and, using some of our knowledge from episode 1, get an idea of what this actually does. We'll snap the camera to the ground here after selecting to make this visible in map view. We've selected a craft already, so we'll go ahead and press this launch button. Of course, remembering that we didn't actually add any components to our structure yet, we won't expect to see any physical items on the ground surrounding us. However, if we go into map view, this new balloon icon has appeared. By selecting it, we can target it, or look at all of its orbital parameters, turn it on and off, and so on. If we then go back into the player view, we'll see that its location has been targeted. This is about all that we need to show here. So let's go back into the Planet Designer. Back across here to the Planet Objects tab. Let's recenter the camera. And then look at the next option. This is called Flatten Terrain. If we enable this, we then get a set of inputs. The elevation above sea level. Remember, this is very different to the elevation given here. It just so happens in this planet that our elevation above sea level of the structure, which is chosen as the elevation for this flattener by default, is very close to the elevation above ground level, which is of course 0. However, in some planets this could be off by several kilometers, so that would be plus or minus 2000, let's say. You do keep an eye on this. Let's change the elevation of this for demonstration purposes to 100. And then the inner and outer radiuses, which are given in meters, we'll reduce the outer one to give a sharper transition. If we then rebuild, the view will have changed somewhat. Let's scroll out a little bit and see what's happened. Now this interesting circle has been added. Let's center the camera back onto our structure. And the structure has been moved upwards to ensure that it has this constant 0 elevation above ground level. Of course, you won't always want to have something this obvious. Here we've used values which are to clearly show how this flattened terrain works. In reality, you would want to increase the outer radius as much as possible without affecting the planet's terrain so that the transition is very smooth and looks believable. Let's now go ahead and add our first substructure or component to the structure. We have selected it and now press this substructure button. There's a quite long list of components here. It's definitely worth browsing through these and taking a look at what there are, but for now let's just go ahead and add the quite basic moon base. Manipulation of the substructure components is achieved very easily through double-clicking on them and then using the gizmos. Very similar to the structure. Just do be careful when you've got multiple items that you're selecting the correct one. Sometimes you'll find that this double-clicking just won't work and you'll need to go back to the tree and manually select which component you want to move. So it's in situations like this that giving components or structures meaningful names, for example we could call this center pad, will be really useful and it will pay off later on. Let's add a few more of these components to our structure. For now, we'll just randomly place these to demonstrate some further concepts. In addition to this main structure, which you could think of as a group of all of these components, which can now be moved around separately, there are also component subgroups. For example, we could make this fuel tank down here to be a subcomponent under the center pad. This is achieved by dragging on top of the center pad. You see now there's this extra drop down arrow which has made this and this connected. We can now move the center pad and it will move the tank with it, but it won't move the tiny cylinder or crane. The best practice for adding components to a subgroup is to drag and drop after setting a part's scale, as adding a component in a substructure to a non-default scale component will result in unwanted scaling. That's a bit of a mouthful, so let me just demonstrate this. It's possible to click on one of these, let's say the crane, and immediately add a new substructure under it, like so. Now that looks really good, and we now have this crane acting as a substructure. However, if we were to use one of these options, let's delete this and try again, and change the local scale, for example, let's increase the width of it to 2. If we then go ahead and add that air traffic control tower in again, you can see that has also suffered the same distortion. But when we go into its local scale options here, it has unity in each of these options. This is quite an unwanted thing to happen, unless of course you've uniformly scaled this crane and just want everything in this subgroup to be really large. If we had used the procedure which we used back up here for the centre pad and fuel tank round, that wouldn't have happened. So if we delete this, select the structure, add that air traffic control tower back in as a part of the main structure, move it to where we want, and then add it to the crane, you see we don't have this issue anymore. We can select the crane subgroup and move the whole thing around. This might seem like quite a lot of unnecessary detail and subtleties. Unfortunately, this is how a lot of structures editing is. There are lots of user interface items which you'll just want to get used to, the manipulation gizmos and things like that, but it really isn't too difficult. It might look quite overwhelming at first, but after a few hours of playing around with these structures, you'll become quite natural at it. As I pointed out earlier, we have the local scale and local rotation. We'll probably be looking at the local rotation in a little bit more detail later in the video, but for now we just need to know that these are the 3 main axes shown up by the green, blue and red gizmos, and putting in a value in degrees, which can be positive or negative, will result in rotating the part. Sometimes the results really won't be what you're wanting. And an easy way to know exactly which of these axes you want to use is to remember the standard order RGB. This is the red axis, and rotating a component around this red axis will be achieved by putting in a degrees value in the first box. Rotating around the green or central axis, in this case the vertical one, will rotate it around as we saw in this direction. And then finally, rotating in the last axis, the blue one, will result in it rotating like so. It is really useful that these automatically update. It makes it a lot quicker and easier to play around with that. Just don't forget to rebuild the planet occasionally and save your work. As we mentioned earlier, for optimizing performance, the structures have levels of detail quite similar to the planet's terrain. These controls are found under the structure group. Let's take a closer look. We have a load distance, which is given in meters, and then 3 LOD, and then a number, distances. This is really quite simple. This distance here, given in meters, is how far away the player's craft. Remember, the player's craft is simulated with the camera in Planet Studio. So we can do the equivalent of zooming out. Unfortunately, this structure isn't quite large enough, so let's just go ahead and make this easier to see. We'll make the structure really large, like this, and then go back to here, and we should see that around 100 kilometers of altitude this will disappear. So let's zoom out until we see above ground level 100. It's a little difficult to see, but you should be able to see there the structure disappears. And that is because we've left the load distance. There are then 3 levels of detail here. These act essentially as multipliers for this base load distance number. You can add or remove additional ones to further tweak the performance. So here we can see the highest level of detail will be loaded from 0.25 times this load distance to being right up against it. And this is confirmed by looking at the current LOD readout here. As we zoom further out, we'll see that that number decreases until finally it reaches 0 and then not loaded. There aren't many cases when the LOD values need to be changed, but for some very large structures you might want to adjust the base load distance number. This might seem like some slightly unnecessary detail, and it's true, for many structures you just won't need to change this, but it is useful to have a clear understanding of how it works. Let's delete this structure and start fresh. There are 2 different types of components. The first of them, which we've seen so far, are these complex models. They have many vertices and quite a lot of detail to them. However, there are also the concrete cube and concrete cylinder parts. These are what we call primitives. At first, this might look very boring. Let's just increase the scale to make it a little easier to work with. However, there are some things which you'll quickly notice that are different to the standard models. For example, we have here a colour input to change the colour. We also have texture tiling to change the scale of the texturing applied. Finally, the standard local rotation, and we can move it around with the gizmos. Some constructions are best made using the detailed models, but for others, using these primitives as building blocks will generate some impressive results. The primitives use very little memory space compared to the detailed models because they have so few vertices, so I recommend you try to use them wherever possible for optimal performance. Let's load in the cylinder one as well, and increase the scale here to be able to visualize it better. Although it might seem quite impossible to build complicated structures out of just these 2 shapes, you'll quickly pick up how it's done, and any seasoned Minecraft players will immediately know what they're doing with this. In addition to these primitives and detailed models, there is one further type of component. These are the light point and light stand components. The first thing that you'll notice is there's nothing to be seen with these. They are effectively empty. However, if we add this and then launch a craft in, remember snapping the camera to the ground and then launching, we'll see that something quite interesting happens. Using time warp here, we'll increase the time speed and bring us around to the night side of the planet. As the sun sets and darkness falls, a light turns on at the location we set. These can look pretty impressive depending on their placement. Remember that the light is omnidirectional. That is, the light shines in all directions. Let's add the other type of light though and see what that one does. This one is light spot. This is effectively the equivalent of the spotlight part. There are some additional controls which aren't there with the light point. For example, changing the rotation so that the blue axis points in the direction that we want the light to go. So if we increase the red axis first of all by 10, or -10 in this case, and then rotate the green axis by 180, we will then have our light source or spotlight pointing at the side of this cube. Let's check that what we've done is actually correct and that this will work. Finding where our cube is again, and then increasing the time speed till the sun sets. And there we go. The spotlight is functioning. Depending on the scenario, you'll need to decide which of these two light types to use. Launch locations are managed in a very similar way to structures. They appear in the Planet Objects tree with a balloon icon and can be easily moved around as required. Let's create one and see what happens. There is no model associated with the launch location, but it's still possible to snap a camera to it. We can also snap to a structure. For example, if we were to move our launch location up to here, above our huge cube, and then click snap to structure, it will go down to the optimal height above the top of the structure. If we now launch our craft again, this option will have appeared for our new launch location, so we can launch on top of the cube. Be aware though that in a completed system, in order to get these to appear, you will need to update the launch locations in the Planetary Systems Designer. They'll then appear in the system's list of launch locations, and then ultimately as the default set of launch points in players' sandboxes. A note on this, it is probably worthwhile spending some time thinking about whether you want to add launch locations in this way or not to your structures. While adding them will enable more players to reach the constructions quicker, it may be that your system is designed to encourage exploration. If you don't set a launch location, I would recommend enabling the show in map view that we looked at earlier. This will enable players to target and find the structure. For planets packed with structures, even this may end up becoming overcrowded though, so do choose carefully. It may be in this situation that you want to add secret Easter eggs, in which case ensure that neither launch locations nor map view visibility are present or enabled. However, with these secret Easter eggs, a word of caution. While they are an intriguing concept, my personal experience is that they're very unlikely to be found or publicised. What seems easy to find for you in the map view that you've been working on will likely be impossible to find for players who have never seen your celestial body before and haven't spent hours carefully creating the structures. Your hard work may just end up going completely unnoticed. This isn't to say, of course, that unmarked locations are a waste of time, but do consider the balance between the effort that you put in and the chance of discovery by ordinary players. These structures are very new to the game, so I think it's appropriate to spend some time with this video discussing some philosophies for getting the most out of them. I've spent quite a lot of time working with structures for ESS 4.0 since their release, and I've learned 3 key points. The first key point is having a clear idea of what you want to build before starting. In my case, I had already planned the locations, where they would be, and what their size was before the release of the game patch. However, if you aren't in this situation, making some rough sketches or even just a quick description of what your desired outcome will really help. I found it's easy to end up just throwing the detailed models onto the planet and producing something which looks quite boring. The second point is to understand the tools or building blocks available to you. This is easily accomplished by taking a close look at all of these individual components and learning about which ones are available to you. Often one of the most detailed models can be used in a very strange way to produce some unique results. For example, I've used runway roads as wiring and a fuel tank as a biodome. And personally, I think this has been quite successful. If you know what can be achieved with all of the models, it will also help to inform your initial design, ensuring that you avoid very difficult or impossible geometries. And finally, attention to detail is probably the most important thing when working in Planet Studio, and structures are no exception to this. Small things like making the location visible in map view with an interesting name, ensuring components don't clip through each other or float in mid-air, unless of course you intend that to happen, will just add a level of quality far quicker than an excessive use of detailing. Of course, remember to have fun though. While planet editing can sometimes be quite a complicated thing, it is also meant to be enjoyable. And I can say that working with structures is probably the most exciting and sometimes most frustrating thing I've done in the game for a while. It's really breathed new life into Planet Studio. And on that note, we'll be ending the 4th episode of Planet Studio tutorial. In this episode, we looked in detail at structures, what they are, and how they work. We also discussed launch locations and the methods used to make structures discoverable. Finally, I shared a few ideas for maximizing the usefulness of this exciting part of Planet Studio. Next episode we'll be diving into the world of biomes and textures, so things are about to get quite interesting. As always, thank you for watching, and I hope you've enjoyed.